In this lecture, we will be talking about superposition and how we can use it to simplify our analysis of circuits. And a very important thing to know about superposition is that it only applies to linear systems, right? So you cannot use it if your system is not linear. So what is superposition? Well, when you use superposition, you can consider the effect of each independent source separately, and then at the end sum up all the contributions. So now what does that mean? Suppose in this example I want to figure out what is this current IR, and in my circuit I have two independent sources. I have this current source here and I have the voltage source. So let's say I want to analyze this circuit using superposition. So what do? I consider each source separately. And what that means is you have to turn off the other sources. Now, how do I turn off a source? Well, I set it equal to 0. So for example, if I want to set a voltage source equal to 0, so I replace this voltage source which has an actual voltage with the voltage source that has a 0 voltage. So when a voltage source has a 0 voltage, we have seen that actually it's equivalent to a short circuit, right? A short circuit also has no voltage over it, so there's no voltage drop over my short circuit. And just like a voltage source, the current through it can be anything, right? So a short circuit is equivalent to a voltage source that has a 0 voltage. And so what it means, when I talk about setting a voltage source equal to 0, it just means replacing it by a short circuit. So let's say I only want to figure out what is IR if I only consider my current source. In that case, I want to set my voltage source equal to 0. So I replace it by a short circuit, and I calculate what is IR when I only have now this current source left. Okay, so next I need to do the same for calculating the effect of just my voltage source here, and I want to set my current source equal to 0. Well, what happens when I set a current source equal to 0? Well, setting a current source equal to 0 means I replace it by a short circuit. A short circuit is nothing more than a current source where the current is equal to 0, right? Because for an open circuit there is 0 current flowing, and just like for a current source, the voltage across it can be anything. So setting a current source equal to 0 basically means replacing it by an open circuit. So I replace my current source by an open circuit, and I can now calculate what is the IR when I only have the voltage source. So what have I done? I've basically calculated what is IR when I only have the current source and my voltage source is set to 0. I also looked at what is IR when I only have the voltage source and my current source is equal to 0. And so when I have both sources, when I have both the current and the voltage source, IR is the sum of these two contributions. And that's the principle of superposition. I can consider each source separately by setting all the others equal to 0. So I have more than two sources. I take each one by itself and set all the other sources to 0, which means replacing them by open circuits or shorts, depending on what type of source they are, and then at the end summing all the contributions. And again, keep in mind, this only works for linear circuits. So if I were to have nonlinear elements in here, you cannot apply superposition. Also, remember, these elements are only linear when I'm talking about currents and voltages. So if I'm talking about calculating the power, I cannot just find the power with one of the sources separately and then sum up all the powers, because in power this system is not linear. So that's the principle of superposition. It's a very powerful analysis technique, which only applies to linear systems.